from same group or same set of data points we have. So in plant A, we are getting sample before PM and after PM. PM is proactive maintenance. So before proactive maintenance plant A and after proactive maintenance plant A, yes, right? It means we have same group of data samples. Again, the test hypothesis would be the mean of A plant or mean of B plant is same. If you are getting sample, we can say X bar A, X bar B are same. Alternative would be that X bar A and X bar B is not same. Also, mean of A and mean of B are not same. We're testing this hypothesis with this data points. The calculation is likewise. So we say so as data is of same group, so we say let's take a difference into consideration and then calculate this formula. So if we run this calculation on this data set available with us, or you can say values available with us, so we can do like this. So we say difference. The mean difference would be this minus this. You can take absolute value. Again, we take standard deviation difference. The root of n. So formula would be what? So we say that let me go back to my whiteboard. The formula would be T pair test. Mean of difference. Then we have standard deviation difference divided by root. That's the formula. And standard deviation difference. So let me put the values. We ideally need to do the differentiation from the values part. So if values aren't there for sample per se, we are doing like this. Otherwise, we should go like this. So let's say I'll take a plant A and plant B in sheet 2. The right way to do the things. I'll take some sample values. Then we have difference in observation is what we are saying, this minus this. Then we are getting a mean of its difference, average. I'll take average. And we say standard deviation of population. In Excel, we have formula. That would be right figure. So rather than taking this as earlier, we don't have the data points. That's why I've taken the variation. But ideally, we should take an as a difference of observations. So this is my mean. This is my standard deviation. Let's put the values here. So mean I have difference mean is 1.5. Standard deviation I have with me is 1.7. Yes, 1.7 I can take. Divide by root of and we have how many numbers we have with this? 6 numbers are with this. So n is common in both. 6. So let's calculate this value. 1.5, 1.7 divided by root of 6 would be 6 root 2.4. 4.5. Let's take to 4.5. And when we divide 1.7 by 2.45, we are getting a value like 1.5 divided by 0.69. So if we go 1.5 divided by 0.69, we are getting around 2.17. That's a T value of calculations. Now again, degree of freedom we have with us 6 minus 1, that is 5. Then significance level we are testing 2.5, and T test value we are getting around 2.7. Now let's validate this data with a previous data points. So earlier also we have tested like value. So we were getting around table value 2.2015. So with the same data points and T table value, we're getting 2.015. And T calculate value, we are getting 2.17. As the rule stated earlier, as my table value is 2.15 and T calculate value we are getting on right hand side, that is, let's say this point. So if this data is on right hand side, I'd say my alternate hypothesis is true. If you are getting data right this side, we say that we are having null hypothesis true. So differentiation, they are not, they are, when you say paired, this use cases where the data is paired, both are having same mean is and false.